Hello and welcome back to the second part of module number 2, and in this section I'm going to talk about standard library, and it will be part 1 and what is built in to the library and what it is. I mentioned that in this previous section in this presentation in module number 7, but I also talked about it in other times. So I want to start focusing on it a little bit more in depth so you will have better understanding. So again, one of the things that I will repeat again and again, Python syntax and structure are already built in to any platform that you are using. If you are using Python online or using in your own desktop or on your own machine, it has some structure. So I want to make sure that the structure or the syntax are already embedded into you. I want to add another component, which is the libraries. The Python standard library is a collection of modules that are distributed with every installation of Python. It is basically the tools and the interface that provide us the ability to apply different application. Example, in my previous presentation, I went over to one of those libraries and ability to do that. Beside the standard library, there is also Python package index or PyPI, which is the official third-party repository for everything, from a simple module to a little bit more extensive framework written by other programmers. As you can see, there are almost 100,000 packages in that platform. And again, this is part of the open source environment. I'm coming from the open source R. We are right now at the same level. We are talking about 10,000, not 10, but 100,000 packages, same as Python, even though Python is a little bit older and much more stable. So when we are going to start spending the next couple of lectures covering commonly used module in the standard library, we will spend the rest of the semester covering a third party. When I talked in module number 1 and I introduced you to Python, one of the things that I talked about was the ability to extend Python to as a server, a web server, and ability to apply additional element. This is part of what I want to cover in order for me to stand by my word that that's the objective of the class. So standard library, it's built in. It's already learn about different types of data such as numbers and lists as part of the core foundation of Python. But we also didn't import anything to use them. So however, the standard library that actually defines those types as well as many other built-in components. So the idea here is we are going to cover in this section, we are going to cover the built-ins as defined by the standard definition. There are a few buildings in defined as the idea of what it holds. Example, true, value of the ball type, and false is the value of the ball types. And again, in this case, A is true, B is false. If A is true, then print A is true. Else, again, the structure that we already understood or work with in order for us to create that. One of the things that is really important is a simple to the no keyboards in many other languages such as C++ or Java or even JavaScript. And so the idea here is again try database equal my database, and again ability to pull out from a database and be able to export that or to analyze that database in order. I will talk more about that as we go along, but for now let's talk about what is non-implement. Return from a comparison operation is not defined between two types. So the constant is mean that it used in conjunction with rich comparison method, and we will do that, and we saw that already where we compare two things using IT with both ends or the EG on the both ends in order for us to do a comparison, in order for us to do that ability. And we saw that, and a simple example is A smaller than B. And if we will do the IT comparison, we will see that what it gives in order for us to build an argument out of it. So the building of A, class A and class B, and again the idea what it is, ability to apply it, ability to emphasize on it, and see how I build my arguments on it. I provide the definition using the IT ability of self-value, and then ability to apply that, and ability to define the EG, and again define it. So you're going to do comparison and an A with a B and return with something else. In B class, it did the same thing, basically an ability to apply that in order for me to do that. Those are things that we are accustomed to extend the syntax, not use in any built-in function. So again, I'm going to show you an example of it. Two dim lists, and I'm going to define them, and I'm going to apply to this in order for me to find out more. Last time I gave you on the canvas, I gave you a list of functions, and I felt that I did not do my job because this was just basically list of function. I want to repeat it again about the built-in function, and it is really important that there are a huge number of built-in function in Python. I cannot cover all of them. So we already see some of that. I talked about that in the lectures about that, but it is a good remind you of those built-in function. Time module is responsible for providing time-related function and convention methods. So let's talk about this type, just again using the standard library in order for you to display time. So time return the time in seconds, since typically how it display. Time.sleep extends the execution for a second. Time.clock returns the current process time in seconds. So here we are creating two timing function which measure the press of a call of time. And how did I do that? Import time. I will define the timer. I will define the CPU of underscore timer, and I will do a print in order for you to allow to understand what it is in order for us to understand. So there are standard additional use of time methods. They're all built in part of the structure underscore time class. So we will look at that first. And the structure underscore time class is also defined in the time module. It is a class which is simplified by 9 attributes for describing a particular time. We can describe, example, year, month, day, hour, minute, second, etc., etc. Again, I'm providing you with example that you'll be able to see, and again, a table of possible format for string argument can be found here. And again, I try to give you a layout of how the structure is converted. And again, this is the outline of how to do that in that time. So time, and I'll be able to apply, and able to describe, and local time, and be able to define exactly what it is. 2015, I should have said 2020, but again, notes that I had for a long time. So one of the other important thing, and one of you already asked me about, is the system. And the syst mode provide access to some variable or maintained by the interpreter, as well as some methods for interacting with the interpreter. So it allows you to receive information about runtime environment as well as modification to it. So the use of module is the import sys statement that is embedded. And how do we do that? Input system for I in range, and I will give some dimension to it, and I will ask the Python interpreter to print system argument in that sense. So it will give me 0, 1, 2, 3, and 4, because that's how I lay out, in order for me to give me some arguments that I can use in my ability. I can import a system, I can print path has numbers, and I can apply what it is. Again, one of the things that some of you already complain is the error message. So one of the things is no module name math was embedded into this idea. So this is something that I need to be aware of or be consist of, and it happens to me quite often, as probably will happen to you. So how to resolve it? Sometimes you just ignore it, or sometimes you just imported the math into that. In order for you to do that, math is part of the library, the standard library that is usually embedded. And again, I try to show you a little bit of dictionary that contains the model that are being imported, a copy, a main, and so on. And so you will have better understanding what it is in take in order for you to use the syst library, standard library, into your program or to your Python path in order for you to apply to it. And again, I used the default, and I used dates and so on, and in order for me to apply to it, in order for me to display that, there is a syst standin, syst standout, and syst std attribute to hold file objects corresponding to the standard input, the standard output, and the standard error, and the ability to provide attributes into the module in order for us to display that in that order. So again, we can also use the system exit, which is a function used to exit a program gracefully. It's really important to you to understand that, because if you are uploading a system, or you are uploading a function or a package, you need to make sure that you will exit it, otherwise it will cause some problems. And this is the way for us to do that gracefully. Another function is OS, and OS module provide a common interface for operating system dependent functionality. Most of the functions are actually implemented by platform specific module, but there is no explicitly call them as such. So the idea here is that we already seen how to use the OC module in one of my example in module 3 and module 4. So now we are going to build in function that will open and close files, but also extend file operation. So OC dot rename, and it will rename your file in order for you to do that. So it will present the current name and the new name, and will rename the file that you want to work. Or oc.remove will remove the existing file or name file. So again, this is a powerful functions that I want you to become familiar with, and there are a number of the dictionary services provided by the OC module, and again, list of directories, list of all the files or in the directory. Get crowd is the current directory, and oc.c directory name, and it will change the current directory. Again, making a directory, remove directories, and so on and so on. It's part of you organizing your library the way you want to, in order for you to feel more comfortable in your environment, in order for you to apply. And again, the idea of OC walk is a path method to generate directory path or directory names or files for each directory found in the directory tree root of the path. And again, example and how to apply to it. I gave also the idea of the size or the time or the hard link and the services embedded into that. LS is the ability to display that, the ability to open it, ability to review it. So all those things, I want you to become familiar with those terminology, those functions. If you are running into this example, and my fault, I did that example in Python 2.7, not 2.9. I do apologize, but it's all notes that I had in mind. So, but it will work fine in your new version of Python. Import, you can import system, you can import OC, and again, what it will entail and how to apply that. So that's it for this module, and I hope you enjoy it. I will extend the library, the standard library functions next module. I hope this is covering the basics so you will feel more comfortable. And again, I open to your questions or your complaints or your ideas, and I hope you enjoy that. So I hope that makes sense. Talking to myself is not a very pleasant thing that I like to do. So I wish we had a class face to face, so I'll be able to show you all of it. Again, ask questions. Your job is to ask the question. My job is to answer those questions. Please feel free to ask those questions. Until next time, enjoy. Bye. Whew.